In this video, we're going to be taking a look at quadratic functions and their graphs. Mostly we're not going to be graphing these, we're going to be analyzing equations to see kind of what the graph might look like just by looking at the equation. But we're going to start off first by graphing the parent function so you know what a quadratic equation looks like. All right, so the parent function of a quadratic equation is f of x equals x squared. Quadratic means that the degree of the equation is 2. So all graphs with degree 2 are going to have a certain look about them. So let's find out what this graph looks like. So I'm going to just create a nice t-chart, and I'm going to say f of x, which is also y. Okay, so I'm going to plug in some values for x. These are the ones I usually use because I know what the graph looks like. But from these values, you'll see why I use them. So if I plug in a -2 into my f of x function, I get -2 squared, which is 4. And -1 squared is 1. 0 squared is 0. 1 squared is 1, and 2 squared is 4. So when I graph this, I get a graph that looks like a nice curve. Almost looks like the letter U. This is called a parabola. And all degree 2 or quadratic functions are graphs of parabolas. Let's take a look at the word vertex. The vertex denotes this inflection point. This is the lowest point on this graph, and it has a coordinate of 0, 0. Okay, so it's the lowest point on the graph. It's the reflection or the inflection point. Parabolas don't always have to face up or open up. They can open down. So the inflection point for a parabola that's opening down would be the highest point on the graph. It's where the graph turns from either going down to up, or up to down. All right, so for a basic parent function of f of x equals x squared, the vertex is 0, 0, and this is what the graph looks like. But not all parabolas have to have a vertex at 0, 0. They can be moved left or right. They can be moved up and down. And like I drew in this picture right here, they can actually be flipped upside down and open down. So what is the basic or the generic form of a parabola? What does that equation look like? So we're going to ignore stretch and compresses right now, and we're just going to look at the form of a quadratic equation, something that's going to be graphed like a parabola that has no stretch or compress. So what does that equation actually look like? It looks like this g of x function right here. So just the basic form is plus or minus parenthesis x minus h squared plus k. When I graph this function, it is going to become a graph that looks like this, or that looks like this, and this point here will be the vertex. It's going to look exactly like your parent function that I graphed above, but it's either going to be moved left or right, up or down, or flipped upside down. So how do we know what's happening in this graph or to this graph just by looking at the equation? Okay, so the sign in front of the squared term, right? This is my squared term. Its sign, either positive or negative, determines whether the graph is going to, if it's positive, it's going to open up and look like this. If the sign in front of the squared term is negative, it is going to be facing down like this. Okay, that's called a reflection. The graph is being mirrored or reflected across the x-axis if it faces down. If it faces up, it's considered no reflection whatsoever. All right, so I want to draw your attention to this. we must write our equation with an x minus, if there's a number in parentheses, an x minus h, okay, and square it. All right, if there's a plus sign, we have to write it in terms of a negative. So h is our horizontal shift, and a horizontal shift will move the graph left or right. So for instance, if h is a positive number, the graph is going to be moved to the right. Okay, if h is a negative number, the graph will be moved to the left. All right, so what does the k value at the end look like? Okay, so this right here, our equation needs to be written with a plus sign. If k is positive, the graph is being moved up. If k is negative, the graph is being moved down. Okay, so those are all the things right now that we can do to our basic quadratic equation. We can state whether it's going to open up or down just by looking at the equation. We can figure out whether it's going to be shifted left or right, and we can figure out whether it's going to be shifted up or down. So how do I know where the vertex is going to be? The vertex, the equation, actually tells us. This form of the equation is called the vertex form, and it gives us our vertex. Our vertex is h comma k. So if we can identify h and k, we can identify the vertex of our parabola. So let's work through some examples. So here the instructions say state of the parent function f of x equals x squared is being moved up, down, left, or right, and by how much. Then identify the vertex. So I'm going to go ahead and write just the generic equation. Oh, plus or minus x minus h squared plus k. And I want you to notice that this lines up really nicely with the equation I have here. I don't have a k value, right? I have this guy hanging off here that should be added. I don't have a k value, so I'm going to add the plus 0. I also don't have a sign, so I'm going to add the plus sign to it. And I'm supposed to have a negative h, but I have a positive h. So I'm going to rewrite this with a plus. I'm going to rewrite this plus as a minus plus 0. All right, so now I can pick out my h and k value, right? I have a plus minus x minus h squared plus k. H is going to be negative 7. K is going to be 0. So how do I know whether it's being moved left, right, up, or down? This is horizontal. This is my vertical. Horizontal is up, down. Horizontal is left, right. Vertical is up, down. So h is negative. According to my instructions, a negative h value tells me I am moving left by 7. Okay, we're moving the graph left by 7. So now my graph, instead of having a vertex at 0, 0, it's going to be moved left by 7. Okay, this will be negative 7 on my x-axis. And I can find my vertex by just doing h comma k. So my vertex is going to be at h comma k, negative 7 comma 0. All right, so let's do another example here. So I'm going to go ahead and write my generic equation here and see what things I have missing. Plus or minus x minus h squared plus k. Well, it looks like I'm squaring x, right? I'm squaring x, but there's nothing being subtracted from x. Okay, and I do have a nice positive sign in front of my x squared term, so I'm going to rewrite my equation as a plus. I'm going to move it over so I can rewrite it as a plus. I need to have an x here and something being subtracted from it. Well, I don't have anything being subtracted from it, so really what I'm doing is I'm subtracting 0 from it. So if I compare it to my generic equation again, x minus h squared plus k, h is going to be 0. And k is going to be 7. Okay, so I have a horizontal shift of 0, so I'm not moving left or right, but I am moving, right, horizontal. This is my vertical. Okay, k controls my vertical, right? So I am moving this graph up by 7. If k is positive, my graph goes up by 7. And my vertex here is h comma k. H is 0 and k is 7. All right, let's look at another example. So let's compare this to my generic equation. Plus or minus x minus h squared plus k. All right, so again, this equation has a plus in front, so I'm going to add the plus in front, but I'm not subtracting anything from this before I square it, so I'm going to add a subtraction of 0. And now this term is supposed to be added, so I'm just going to add that term at the end. Now I'm going to go ahead and write my generic equation here. X minus h, so I can pick out my values, and you can see that h equals, right, this guy right here, h equals 0, k equals -10. All right, h controls my horizontal shift. So I have no horizontal shift, its value is 0. K controls my vertical. So I have a nice vertical shift, right? A -k value tells me I'm going down. I'm going down by 10. What's my vertex going to be? H comma k, which is 0 comma -10. Okay, let's do one last example here. Let's write my generic equation, plus minus x minus h squared plus k. Well, this one looks pretty close. I have a positive out in front, so I'm going to write that positive. I have my negative that I need, so I'm going to leave this alone. The only thing I'm missing is my k value. So since I don't have it, I'm adding 0. So now if I compare this to my generic equation, I can see that h is 10 and that k is 0. So again, this is my horizontal, this is my vertical. Because my k value is 0, I have no vertical shift, but my h value is positive, so I'm moving to the right by 10. And my vertex is h comma k, so it's 10 comma 0. All right, so I want you to this first section of homework, I want you to match your graphs up to some of the equations I used here and see if you can find whether it's being moved left, right, up, down, and the vertex. My second video will cover the second section.